Hello, welcome to my channel. In this video, we'll unravel the secret behind laser barcode scanner, explore the precision of laser printers, and dive into the cool world of laser cooling. Get ready for the journey into the fascinating uses of lasers in technology. My name is Ayush Kumar. My USN is 23CS 1600, and I am from first semester from the Department of Computer Science Engineering. And the subject which we are going to study is applied physics, and the subject code is BPHYS102. And the topic which we are going to learn is basically laser printer, laser scanner, and laser cooler. Let's get started. So these are the three topics which we are going to cover in this video, which are basically laser printer, barcode scanner, and a laser cooler. Let's get started with the laser printer. So first, what do you think of a laser printer? So I'll explain it to you in a simpler way. Laser printer is like a high-tech marker. It uses a laser beam to draw on a special drum, which attracts toner, which is basically like a colorful powder, and then transfers that drawing onto a paper, which is heat sealed, giving you crisp prints, which is fast, precise. It's like magic with technology. Now let me explain what is a laser printer in terms of technology. A laser printer is a type of printer that uses a laser beam to produce a high quality text and a graphic on paper. It works by directioning the laser onto a photosensitive drum, as you can see in the video. Which can create a electrostatic image. This image attracts a toner, which is basically a cartridge of ink, which is then transferred to the paper and then fused using heat. This results in fast and precise printing. Now, let me explain the all the components in a laser printer. Now, laser scanning unit. The process begins with the laser scanning unit. It projects an image of the content onto the photo conductor drum, creating an electrostatic image. Now, photoconductor drum assembly. The photoconductor drum is coated with a photosensitive material. The laser light discharges the drum in specific areas, as you can see, creating a latent electrostatic image. There will be some coronavirus. The coronavirus applies a uniform positive charge to the photoconductor drums. The areas exposed to the laser have a reduced charge due to the discharged electrons. Now, what does a developer roller do? The developer roller carries the negative charge donor particles. These particles are attracted to the areas with higher charge on the drum, forming a toner image. Now, next, we have a few more. As you can see in the diagram, there is a toner hopper. This is where the toner is stored as the developer roller rotates the picks up toner and particles from the hopper and transfer them onto the photoconductor drum. Then the transformation of electrostatically charged donor image on the drum is transferred to the paper, which has a stronger negative charge applied to it. Fusing. Fusing is basically there will be a paper which passes through a fuser unit. The unit uses the heat and pressure to melt and fuse the donor onto the paper, creating a permanent image. Now, there would be also a discharge lamp. After the donor is transformed to the discharge lamp, it neutralizes any remaining charge on the drum, preparing it for the next printing cycle. Next, we have a barcode scanner. What do you understand by a barcode scanner? Let me say it to you in a simpler way. So, think of barcode scanner as a high-tech translator for those zebra-like patterns which are called barcodes. So it quickly reads the lines and turns them into a useful information. Those are basically the binary codes which it translates into the machine understanding language, and it can read all the prices or the product details. It is very handy for speedy checkouts and keeping track of stuffs. Now let me see what a barcode scanner is in terms of technology. A barcode scanner is a device that reads and interprets the barcode, which are coded representation of data often found on products or items, which are basically the binary codes. Now, there are many aspects and things in barcode scanner. Let me explain those things to you. So, there would be an emitter, which is basically a laser. The scanner emits a thin beam of laser light. This laser serves as the light source for scanning the barcode. Now, oscillating mirror. The mirror rapidly moves or oscillates to direct the laser beam across the barcode in a sweeping motion, as you can see in the figure given there. Now, a barcode reflection. As the laser beam sweeps across the barcode, it reflects off the contrasting spaces and bars of the barcode pattern. There will be also a photodetector sensor. That is basically a sensor which detects the reflected light. When the laser beam hits the dark bar, less light is reflected compared to when it hits the light spaces. So next we have a few more things in barcode scanners. As you can see how a barcode scanner actually works over there. So next we have analog to digital conversion, which is basically conversion of analog light signals into the digital light signals. The the varying intensity of the reflected light corresponds to the varying pattern of the barcode decoding. The digitalized information is then processed by the scanner decoding software. The pattern of bars and spaces is translated into the numerical or alphanumerical information encoded in the barcode. This process happens rapidly, allowing the barcode scanner to read and decode the information from the barcode quickly and accurately. The oscillating mirror and laser scanning enables the scanner to cover the entire barcode, capturing the information encoded in it. So that's how basically a barcode scanner works. Laser cooling. What do you understand by the word laser cooling? So let me say you what laser cooling is in terms of easy words. So basically, atoms are like hyperactive dancers at a party, and laser cooling is like a shining a spotlight on them, which basically happens at a party. So when the atoms absorb and re-emit the laser, they lose energy, slowing down their dance moves and cooling the party down to extremely low temperatures. So let me explain this in terms of technology. So laser cooling is a technology that uses laser light to slow down and cool the motion of atoms or ions, reducing their temperatures to nearly absolute zero. It's fascinating method employed in physics and quantum optics experiments. So let me show you how the laser cooling actually works. There are a few components in laser cooling, which is basically Doppler cooling, photon absorption, momentum transform, and cooling effect. So what is a Doppler cooling? The process begins with a group of atoms moving randomly due to their thermal motion. A laser turned to a frequency slightly below an atomic transition is applied to the atoms. The photon absorption and emission. When an atom moves towards a laser, absorbs a photon, it gains momentum in the direction of the photon. The atom then quickly re-emits the photon in a random direction. Momentum transfer. Due to the conservation of momentum, the atom gains a small amount of momentum from the absorbed photon. But since the emission is random, there is a net loss of kinetic energy in the direction of the laser beam. Cooling effect. This process called Doppler cooling repeats as long as the atom are moving. So over time, the collective effect of many absorption and emission event leads to a significant reduction in the average kinetic energy. So consequently, the temperature of the atom reduces. So next we have a few more which contain magneto-optical trap. So, to further cool the atoms, a magnetic field is usually applied in conjunction with the laser. This creates a magneto-optical trap where atoms are conformed in all three spatial dimensions. As the atom continue to lose energy, they become localized. वीडियो बनवे छी आबि गेला पीछे से वीडियो में आबि जेतै magneto-optical trap. To further cool the atoms, a magnetic field is used, which is basically magneto. Next, we have magneto-optical trap. To further cool the atoms, a magnetical field is used applied in conjunction with a laser, just basically magneto-optical trap, where atoms are confined in all the three spatial dimensions, x, y, and z. As the atoms continue to lose energy, they become localized and colder, achieving low temperatures. Laser cooling, often combined with other cooling technologies, can achieve temperatures close to absolute zero. This is crucial for the experiment in fields such as quantum physics, where precise control over the quantum states of atoms is required.